question asks us to draw the molecular orbital picture for this molecule, and to determine how many electrons there are in the p orbital on the central atom. For this molecule, carbon will be the central atom, and it will be sp2 hybridized, which means its geometry will be flat trigonal planar, and it will be comprised of 3 sp2 hybridized orbitals and 1 unhybridized p orbital. That p orbital will be perpendicular to the trigonal plane, comprising the 3 sp2 hybridized orbitals. To draw the molecular orbital picture for this molecule, I'm going to try to draw it in a perspective drawing, showing it kind of going horizontally perpendicular to the screen. I'm going to start with the central carbon atom, and I'll start with the 3 sp2 hybridized orbitals. So those 3 sp2 hybridized orbitals will point towards the corners of an equilateral triangle. And this equilateral triangle is intended to be going in and out of the plane of the board. There will also be an unhybridized p orbital on this molecule. But then one lobe will stick up, and the other lobe will stick down. To help show the three-dimensionality here, I'm also going to draw in a plane where this plane is intended to be going perpendicular to the screen. The sp2 orbitals in orange are perpendicular to the screen, and the unhybridized p orbital is perpendicular to that plane. The carbon atom is making bonds to 3 hydrogens. So there's one hydrogen with a 1s orbital, another hydrogen with a 1s orbital, and the third hydrogen with a 1s orbital. The positive charge, the empty orbital, is the unhybridized p orbital in this molecule. This is the molecular orbital picture for CH3+. The central atom, the carbon, has an unhybridized p orbital that is empty. It's where the positive charge is. And so the central atom has 0 electrons in that p orbital.